We have all felt this frustration before. You know the information is there, you type in a search, and the computer gives you zero results, all because you didn't use one specific word. For a long time, computers worked like rigid filing cabinets, only finding files if the folder label matched exactly. If you search felines but the folder says cats, the computer sees no match. It slams the door, telling you it found nothing. A human being, on the other hand, understands that feline and cat are different ways of saying the same thing. To build helpful artificial intelligence, engineers had to solve this. They had to teach machines to understand the relationship between ideas, not just the spelling of words. They achieved this by moving away from the filing cabinet entirely. They replaced folders with a system mapping the actual meaning of our language. This new system, called a vector database, works like a vast spatial map. It treats every idea as a physical location in a mathematical universe. To get your data onto this map, it has to go through a mapping process. It has to be turned into a language the map can read. If you have a sentence like, "I am a cat," you feed it into a specialized translation machine. Instead of translating the sentence into another human language, this machine outputs a long list of numbers. These numbers act as a set of highly precise GPS coordinates. These coordinates tell the computer exactly where that specific thought belongs on the map. By turning words into these locations, the computer stops seeing language as a string of letters and starts seeing it as a landscape of shapes and distances. Imagine a glowing grid floating in the dark. The coordinate for cat places it at one specific point on that grid. When we plot the word dog, the machine generates coordinates that land it right next to cat. They land near each other because they share traits the machine has learned to recognize. They are both animals, they both have 4 legs, and they are both common pets. Plotting crocodile places it in a distant map sector, far from the pets. Search for felines, and the system drops a new pin right in the cat neighborhood. Ignoring spelling, it simply measures physical space, checking what sits closest to the search pin. It collects whatever data is physically closest to that pin and gives it back to you. In this system, meaning is measured in inches and miles. If 2 ideas are similar, they are neighbors on the map. This map grows to hold millions of these points, eventually creating a massive, deeply interconnected network of human knowledge. The map holds text, photographs, and audio recordings, plotting them all in the same space. This allows the machine to place a picture of a kitten, the sound of a meow, and the word feline in the exact same mathematical neighborhood. This ability to mix different types of information is why modern AI feels observant and helpful, because even moods have patterns the machine can map. If you ask for music for a rainy day, the machine looks for songs whose coordinates land near melancholy or acoustic guitar. The AI isn't thinking like a person. It is simply looking at a vast universe of data and showing us whatever is closest to the star we are looking for.